Welcome everyone. Safety data sheets. We will be discussing everything with respect to the data sheets that needs to be speaking around it. MSDS as we oh yes, MSDS is Material Safety Data Sheets, which is basically telling you about the hazardous things that might be in operation, what you might be revealing around it, what you might be working with it. It tells you about the chemical composition, the natures, the different hazard, the preventive measures that can be taken. Remember, MSDS has 16 sections, as we have already discussed in our earlier videos altogether. The 16 sections go around it. I will be speaking around all the 16 section but one. So let us understand and identify the substitutions for the measures of the suppliers. First and foremost thing is the identification of the chemical mixtures, the composition, what has been composed around it out here. Please remember, we can have a multiple composition mixtures. What are the other definite mean of identification in terms of smell, in terms of sight, in kind of feel, in kind of basically the ambience that it comes around it, the supplier details, as in who is manufacturing it or who is transporting it. It will give it you a vivid description, and in case of there are any anomalies, you can always be the go-to person. These are the go-to person to find out other alternatives and the remedial issues. And the emergency phone number. Now this emergency phone numbers are mentioned in a government website always with the suppliers, are available with the suppliers, and hence I'm not mentioning out here because it varies from different countries to countries. Every country would have their own emergency numbers and solutions around there. Let us understand the section 2. It is all about the hazard identification. Now we are talking about classifying the hazard into different level, a low level or an extreme level, in between whatever classification that comes around it. It might be giving a graphical reproduction of symbols with black and white. We will be talking about the pictogram representation in the subsequent slide, I'm sure about it. So any other hazard which relates to dust, explosions, so on and so forth. Here we go with the hazard class in terms of oxidizers, what we are looking into it. In terms of flammability or combustibility, what we are looking into it. Is it pyrophoric? Is it self-heating? What are we talking? Can it burst around? See, look, what are the pictures that goes around it? It's an explosive. Is it self-reactive? We are talking about the toxicity in case of a spillage, in case of a leakage, what happens? What about the corrosive materials? Probably certain materials where it can be not reacting, maybe with a plastic, maybe with a steel, or there are certain chemicals which actually reacts with your plastics, or probably with that matter a steel or an aluminium. It tells you about the corrosiveness when it gets exposed into the air, and the gases which we correct check on will be collecting around it. It need not be only petroleum or liquefied petroleum gases that we're talking about it. It can be pure distilled liquid oxygen that we might be carrying, which is again very hazard classes. See what has been given. This particular signature tells you it is a respiratory issue, it is cancerous in nature, it can cause internal organs to malfunction, very dangerous. Talking about the environmental toxicity, this is the pictograph which tells you with a tree, and then there are certain things which an exclamation marks which gives you as an irritant or a dermal sensitizer, which are of a low risk definitely, but creates a lot of nuisance, a lot of problems on your daily. So let us understand section 2 in terms of composition and information of the ingredients. What are we talking about? We are talking about the chemical identity. We are talking about the most common name, prevalent name, which has been known in the society logically. We can also talk about the batch number, the production number, the dispatch date, the impurities and the stabilizing additive that can be mentioned around here, which probably renders those chemicals useless or redundant altogether. So needs to understand the classification of the substances again. So composition information of the ingredients are the mixture that comes around it, the chemical identity and the concentration, which requires all the ingredients which are hazardous altogether. Remember, GHS stands for Globally Harmonized System of Classification. This is very true and it is universally applicable. I still recollect and I'm still reiterating globalized harmonized system of classification. globally harmonized system of classification that comes around it, which tells you the cutoff levels which will be there around it. There is the firefighting mechanism. Look at it. We have the fine pounder mechanism and the horn factors, which is absolutely with no gauges and maybe with a larger hose. See the hose out here and see the hose out here. Absolutely, which is very fine. Suitable and unsuitable extinguisher media, which needs to be understood. Specific hazard arising from chemical natures of any hazardous material that comes around it. This needs to be understand again and again. We will be utilizing our personal protective equipment specially done for fighting fires. This needs to be demarcated. We need to wear it out. It is specifically inflammable and protects the person from fires. Now we come to the section C, which is accidental release of measures in terms of leakages, breakages. So what are this been required? We require our PPE kits, the personal protective equipment. What are required in the emergency procedure? If it spills into the environment, we keep on hearing the news of petrol, gas tankers bursting it out or leaking in the ocean and spilling on the ocean, which is causing a devastating effect onto the fishes and the aquatic marine animals. We are talking about it. Methods and materials for containment and cleaning thereof. How do we go about cleaning it and restoring a balance in the environment? This is what needs to be mentioned, understood. Where and what are we discussing around it? We are discussing MSDS, material sheet data safety. What is it all about it? Now, talking about the handling and storage in the section 7, that comes about the precautions of safe handling. Yes, the right method, it tells you what is the right method. If you see people are with the PPE kits, they are enclosing everything and probably are putting it into a closed, safe environment. So, that is what we are looking into it for a safe storage, including any sort of incompatibilities, impurities, or any oxidation can take place. In the eighth section, we are speaking. See, the person is with a complete protective equipment, with a eye cover, with a inhaler, with a body mask, with gloves. If you look, everything has been taken care of. The shoes, everything tightly sorted out. Now, what are the parameters goes around it? This is TLV, TWA, and TLV still. What is TLV? People might be asking. It is the threshold limit value. Everything has a threshold limit value. Then would be what is TWA? TWA stands for total weight average. Now we need to understand the threshold limit value a person can go across with it, or equipment can go across with it. What are the total weight average that comes around it? Yes, STL stands for short term exposure limit. What happens? I keep on saying or probably mentioning people in the working in the radiology department of any hospitals are being exposed to radiation. The what is the short term exposure limit that comes around it? So we need to have the PPE things. This is the PPE things, the personal protective equipment, the eye protective equipment, the skin protective equipment, the respiratory protective equipment. This is very important, and the pictograph shows you a wonderful example about it. Let us understand the keywords as been discussed. The threshold limit value time or time weighted average, what you call around it. It is basically for an 8-hour work day. After 8-hour work days needs to be discarded, or a 40-hour work which the workers may be repeatedly exposed without any adverse thing. You need to decide upon the threshold limit value with respect to the time weighted average that comes around it or total weighted average that comes around it. Then there is something called the threshold limit value and STEL or short term exposure limit. Now, believe me, the short term exposure limit for threshold limit values for certain things would be 15 minutes continuously without any adverse effect. Beyond 50 minutes, you might get a reaction or reactive, probably your immunity starts to falter. This 15 minutes exposure limit is only for a day per day and must have approximately 60 minutes in between the exposure. So every 15 minutes that you go around for an exposures of a radiation, you must take 1 hour off and then start for another 15 minutes. So this needs to be understood altogether. This 1 hour off has to be taken care of. Then we talk about the TLV, or the threshold limit value ceiling. This should never breach. Absolutely should always be adhered to during the working exposure. This is what threshold value limit is all about. We should never breach that thing. Then we speak about PEL, or permissible exposure limit. It defines as an allowable limit of an air contaminant to a certain extent, where a person might be exposed on a day after day without any adverse effect. We keep on speaking about having the suspended air particles as far as the air pollution is concerned in various cities, primarily in the South Asian cities. We are talking about it, the high concentration of suspended air particles. How do we mitigate such things? That is what we are talking about. Permissible exposure limit. Talking about the physical and chemical characteristics, what we are looking at is the appearances, the molecular weight, the flash point, the degree centigrade. At what degree it becomes a flash point. You need to understand where it bursts, where it catches fire. The auto ignition temperature is where it catches fire without any help or external agent. It catches fire automatically. That is the auto ignition temperature. The boiling point, certain definitely at certain point at the 760 millimeters of a pressure level. What is my boiling point? What is my melting point? We mention it out. We give up vapor pressures, we give a vapor density, percentage solubility in the air, in the water, the odor, and the threshold. The physical and the chemical characteristic has been disposed as far as these criteria that needs to be mentioned here. We'll talk about the, we'll continue with the physical and chemical properties. Now we'll talk about the flammability concept. So what are the flammability limit? At what percentage? At the lowest end of the thread, can we touch it? What are the upper end of the flammability limits? Probably you are testing your limit altogether. The specific gravity, as in the solubility is concerned, the percentage volatile, evaporation rate, obviously of the water being the one thing. Apart from it, at what rate it will be evaporating. Viscosity is the thickness that comes around it in the soluble liquids. At which is we mentioned the octangle water particle coefficient, which needs to be logged in, and the pH value, the alkaline value or the acidic value of the product. So what are the things that needs to be discussed out here is the flash point. It is exactly the lowest temperature at which a flammable liquid gives off absolute start giving off vapors to form an ignitable mixtures within air. That's the flash point. In other words, the lowest temperature in which a liquid can ignite if a spark is present. So you require an external help, remember. But in auto ignition, the temperature doesn't require an external help at all. It catches fire on its own. So that's a little bit on a higher degree of temperature. Lower explosive limit is where the minimum concentration of flammable gas or vapor by in terms of percentage in volume in the air in which an explosion can occur if a flame or a spark is present. Whereas the upper explosion limit is the maximum concentration of flammable gas in which explosion can occur even if there are certain external element, a certain help in terms of spark or a flame is present. We talk about the hazardous product of combustion. In most, absolutely in every fire, the greatest danger of human is not heat of flame but toxic smoke that fills the area. It renders a person unconscious, if not unconscious, incapable of thinking straight. All anticipated products of combustions are listed here. Fires of the laboratories are far more dangerous than the common fire because of the toxicity of the fumes, which is the danger. We come to the stability and reactivity. First and foremost thing, we'll talk about the chemical stability, the hazardous reaction, the decompositions products, how does it breaks down, if any at all it breaks down. We need to understand those breaking procedures altogether. Possibility of reaction and negative reaction we are talking around here. Conditions to avoid, so prevent any other untoward incidents. How do we get it neutralized? Static discharge, vibration, incompatible materials which should not mix at all, doesn't react at all, what we are looking into it. So it clearly states the stability, the reactivity, and the non-reactions about the equipments, or probably the chemical materials that needs to be done around. We talk about the toxicology information. Very true. It is very complete, concise, and comprehensible description of different toxicological effects that can impact the human health. What are the information? Like the likely route of exposure, let's say inhalation, if you can inhale, or ingest, eat, skin or eye contact. Similarly, symptoms related to physical, chemical, and toxicological characteristic. What are the target organ? Is it your kidney? Is it your liver? Is it your lungs? Is it your spleen? Is it your lower abdomen or upper abdomen? What is it been hurting around it? The target organ, it tells around acute and chronic effect of short and long term exposures, which will make it absolutely pathetic and will have a no return value. So these are all mentioned in toxicological. We'll talk about the definition as well as route of entry. Now, how does it hazardous material enter your body? Probably through your skin, probably through your eyes, probably through your noses as far as inhalation are concerned, or probably through ingestion or through your mouth. Acute health effect. What happens within a STE or short-term exposures? What happens if there is a brief exposure to the material? What happens in case of chronic health effect, which may result in LTE or long term exposure? You have been repeatedly exposed, you are being repeatedly exposed on a daily basis, and it accumulates. People working in the mines as one example who are very susceptible to such kind of exposure. Then we're talking about the symptoms of exposures. Now this might look as what the victim might look. There might be blisters on the skin, there might be the victim might be coughing or difficult to breathing, or they might be suffering for other ailments which can be distinguishedly guessed in cases of asthma, in cases of shaking of your limbs and so on and so forth. Medical condition aggravated by exposure. These terms not easily recognized by non-medical personnel. They are what is to be told upon it. These are internal organs that comes and there are no physical manifestations. So we require a paramedic or a medical professional to understand the medical condition. Then we have the target organs. Some materials harm a particular organs, let's say heart, a liver, a brain. What is it all about it? Talk about the lethal concentration. What are the lethal concentration? What is the effect that comes around it? The concentration of the hazardous material expected to kill 50% of the test animals in a single respiratory or single exposure. What comes in the lethal concentration, which is very low? Probably it causes death in the humans or laboratory animals. That indicates the lowest concentration that tells you. And the very weakest concentration that might actually be very detrimental to the health. Lethal dose of 50. See, this was lethal dose with a low concentration of 50, but LO very very bad and detrimental. The lethal concentration with a doses of 50% actually impact all the 50% of the tested animal population in a definitive fashion, and where in the lowest of the dose of a lethal concentration causes death in all human beings, and absolutely you go around, things cannot be reversed, and these are being caused by evil. So we'll talk about the oral toxicity in terms of pictographs, the signal word that comes around it, the danger, we all are aware of it. We will talk about the categories for everything that comes around it as a warning signs and so on and so forth. The oral toxicity, if we talk about it, toxicity if swallowed, if ingested, if inhaled, what. Now we come to the ecological information. It, ecotoxicity toxicity is both for the marine animals and for the land animals, which has been present out here. We need to understand the biodegradable degradations that comes around it. We will talk about it, bioaccumulative potential, mobility in the soil. We have to understand everything now and then there about. So it is impacting your marine animals, it is impacting your land animals, it is the persistent and degradability, it is detrimental to any living around it. Then we talk about how to dispose the hazardous material on the safe handling procedures, how to get rid of it, how to mitigate such kind of exposures or contaminated things. How do we? What is the right procedure? This is mentioned 13. Now we'll talk about the transportation. Look how it has been transported all together. We have the first coating in terms of first grid wires that comes around it. Then there is a cylinder that is taken care for, and inside it might be your gases that might be taken consumed. So there are two layers that will be taken. Probably this is again fastened into certain of the equipments or transportation thing. So we have the unique number that comes around here. We will speak about it. Transportation hazard that comes around the packaging group if applicable, marine pollutant, yes or no, special precautions which a user needs to be aware or need to comply with. That is what which is very. Now, in departmentals of transportation that comes around, we need to understand what are the proper shipping names, what are the numbers, what are the packaging groups. Everything has to be mentioned around it. With International Maritime Organization, the same thing has to be followed as for your batch production, the date of manufacturing, the expiry date, the group levels, and everything that needs to out here. There comes the transport pick with you, which tells you flammable but liquids, which is self-reacting, absolutely substances which are pyrophoric substances, which is spontaneously combustible substance which in contact with the water emit flammable liquids in a blue colors, oxidizing gases probably it is mentioned in a yellow color, explosive devices it absolutely determines has been given out here. Similar is an exposure devices on the scale of 1.4, 1.5, and 1.6 that comes around it as for your understanding itself. Then we comes to the next level which is there, which is mentioned in terms of complex gas that we come around it, which is friendly to the nature probably, but then it's very economically very pricey, very valuable, so we cannot waste it. Acute toxicity is all about poison, results in death. Corrosiveness, it actually kills the containers as it been transported or being stored in. Marine pollutant is to the aquatic marine animals that has been done. And the oxygen peroxide that we come across it. Now, these are things that needs to be kept in your mind while you are designing toxicity or MSDS. We come to the very last slide is the regulatory information as to the regulatory body, the government that we are talking about. We are also telling about the responsible persons uh, who needs to be connected with respect to the product in question and so on and so forth. This I come to an end of this presentation. Thank you for watching this video.